All right, January 5th, 2016. Let's look at the first steps in making a mold for silicone dome-shaped shell for an electronics cover. So here's a Fusion 360 model of a solid that will eventually be made into a shell, and this is the part that I want to mill. It's about 30 millimeters across. So if we look at the cam operation, I used pocket clearing in the part that I made, and I'll show how. And I ignored this step over should be set manually, and so this is how the milling went. And I have another video that's 30 minutes. This was about a 30-minute. Let's see what this says. Machining time 16 minutes. I don't know why it took 30 minutes. I must have changed something to make it take that long. But in any case, and it, as you'll see, it was a little bit rough, or not rough, but the steps were not very good, or at least satisfactory for making a smooth looking dome like that. So I think probably it needs to have, the pocket clearing was probably okay, although it might be necessary to have several strategies, one for the flat top that we see up here, and another one for the angle at the top portion, and then another strategy for the sides maybe, but some more experimentation. And of course I'm machining this out of wax, so that changes things. So let's try changing some parameters, see what happens. So I'm thinking that I need to step over of 0.1 millimeters instead of 1 millimeter, and then step over of, instead of 0.6 millimeter, 0.06 millimeter, and then go from climb milling to conventional milling, and order it by depth. Smooth the G code. See what that does. It's calculating, so that's different. It looks like it may be finer, at least in some dimension. It looks like it's probably a lot finer in how much it steps down. Let's zoom way in here. So it looks like it's stepping down many more times. So let's have a look at the result of the untweaked, the actual machine and actual object that was machined. So here it is, and you can see, maybe you can see, I don't know, it's a little hard to see, but this is a little bit stair-steppy here. But I want to try pouring silicone into here. So in the actual finished object, I'm going to want to have a positive and a negative side with a little gap in between, so I can, when I do a cast, I'll make a shell. And this is all inspired by this little MP3 player that I've hacked apart, and I put a flip phone battery in it to extend its lifetime and glued it on there. And in the process of taking it apart, I found this cover intrigued me. And how this cover is made, it's a flexible material. If I can pop it off. And it's stretched over the electronics like that. And then it has a key that locks it in around this base that has the circuit board in it, and it has buttons that you can press through there. So I'm kind of creeping in this direction, and the another CAD operation is to do this undercut, because this wraps around and it stretches over and it snaps in this dovetail around the edge. So another operation would be to clear this square out larger so I can put a cutter, a T-shaped cutter like this. So we've got this dome, and then we need to have an undercut like this, so that when we do the casting, it'll stretch around a base. It'll be shaped like this, and this is exaggerated. Then we can have our electronics in here and whatever push buttons, and of course the dome will actually be shaped like this. So this cutter that needs to come around the edge, I need to have a cutter that's shaped like this to make this undercut that's inside here, which is an operation that will require having to do a tool change. Since I'm using a CNC router, a Shapeoko 3, and I don't have tooling, I don't have a tool like this, I may be able to improvise something to cut the undercut, but I have to be able to register the Z from the surface accurately enough to do this undercut during the tool change. And so it might make sense to have several tool changes once I master the art of tool changes in a manual machine like this, where I don't have hard stops on the tools. And so here's an example. Here's some 1/8 inch end mills, which might be good for roughing some of this out. If we look at these are from eBay. I think it's from the Toolman 7 or something like that. So when this slips into the collet of the machine, and is tightened down, the amount that it's inserted matters. So it's probably necessary to re-zero the z-axis, and so you have to be really careful to very precisely zero the z-axis, or else it's not going to cut this slot where you think it's going to cut it. Anyway, so what I want to do is mix up some of this silicone that I have here, pour it in there, and see what kind of results we get. So let's do that. So I've got Sorta Clear 40. I've got a Sorta close to what I'm trying to do mold, and I believe that this is 10-to-1 by weight. So I've got part A. I have never used this stuff before, and it's warmed up to 60 something, 62 or 3 degrees Fahrenheit in here. So here's part B, and because I'm worried about this stuff being maybe a little bit nasty, I'm gonna glove up and see what we can do. All right, so I've got scale, and I'm going to guess at how much volume. I got a stir stick, and I'm going to say that this is 10-to-1, so that must mean that the big one must be the one that's 10 and the small one must be the one that's 1, because it couldn't be any other way. And since this thing is very closely, shake well before using. Let's see what this says. I don't really want to read the instructions in too much detail. Okay. It says pot life 60 minutes, cure time 16 hours. So we're not going to be able to see this cure in real time. So I'm going to shake, and I'm going to put in, I'm just going to eyeball it to some number, like 100 grams, I guess. So that means 10 grams of this stuff, of one, and 100 grams of the other stuff. So let's go for it. Ooh. I assume all this means that I need to use this up fairly soon. Well, maybe I got some fumes coming off of this already. Okay. Of course, I can't mute the coughs out because I got this stuff on there, and if I touch my headset, I'm gonna get silicone. So I'm gonna try 100 grams. Stuff's pretty thick, very viscous. Whoa. Okay. Luckily, it's decimal. Okay, there's 352 grams. So that means I need to put in, wait a second. It looks like I may have bumped the tare because now it says 35 grams. Okay. I think I have a way out of this dilemma. Let's put this on. Push tare. Okay, and put this on. Since we assume these cups are the same, okay. No, it's 35, so I need to put 3.5 grams. Okay, here we go, 3.5 grams of this other stuff. Oops, that was a mistake. Tare it again. Let's call that 0.5 grams and put 3 grams in. Okay. Hopefully that's close enough. Let's get this out of here without glopping up my scale and start the mixing. Okay, so this is way more viscous than I expected. Oops, stir stick didn't last long. Let's mix this up. Hopefully this is going to be fluid enough to be able to actually get into that mold. I don't know whether this is a temperature problem or what, but it doesn't really seem like very good mold material if it's that viscous, but maybe it's going to thin out with mixing. Sorta clear 40. Okay, so there's 60 minutes pot life, so I've got plenty of time to mix this up. The recommended thing to do is to put it into another container and then mix that up too, because apparently mixing is important with this stuff. And I'll save both these containers so that we can see. And then if we were going to be very technical with this, which we don't need to be right now because this is just preliminary experiments. We would put this in a vacuum chamber and we'd suck the air bubbles out, which I am now introducing with all this stirring. Okay, so first level stir, and this is second level stir. And I guess this is warming up because I'm holding it in my hand. Should be nothing stuck in the corners now because it's been poured out of that other container. Okay, so it's starting to feel a little bit different. Okay, so now from watching YouTube videos, I see that one of the ways to try to get the bubbles out is to hold this up high and let it dribble into the mold like this. Supposedly, and then it flows in horizontally. And you might be able to see this has got quite a bit of entrapped air. One of the things that I'm worried about is that this might be exothermic and it might have a tendency to melt the wax that I'm using for the mold. And ultimately this mold, once I get it proven, will be made out of some other material like high density polyethylene or something. Okay, so that looks like it's full. I'm just going to lay this over here on this mistake over here, and we can use that as a test for cure. So it looks pretty bubbly. I'm going to pop my gloves off and get down here, see if this focuses. Maybe you can see how bubbly that is. Yeah. So this looks like maybe it might need to be vacuum degassed. We'll see how good of a mold that turns out to be. The part where the bubbles need to not be is right at the surface mainly. So maybe the bubbles will rise, but when this is injected into a two-part mold, we're not going to get that. We're not going to get any, we're not going to be forgiven because it's going to be very thin, and if the bubble goes all the way through, it's going to be a hole. Okay, so I guess I come back in 16 hours and we see what that's like. It's January 5, 2017.